Okay, so for question 39, rank the following compounds in order of decreasing nucleophilicity. So for the first sub-question here, we have a couple different things going on. The one apples to apples comparison that we can make is that all of these compounds are charged. They're all negatively charged. Okay, so the second thing we can think about is what's the most alike. So between all of these three, we're going to have, obviously one's going to be first in line, second, third. The two that are the most similar to each other are this methoxide and this sulfoxide. Okay, so thinking about the solvent that we're using, that's going to be really important. So we're using methanol, and we're using a polar protic. So polar protic, we know that for polar protics, this will actually, potentially invert nucleophilicity if we're going vertically up and down the periodic table. So if we're going up and down like this, so if we're going up and down vertically, if we have polar protic is going to invert the nucleophilicity basicity trend. So what we're going to have is, poor bases are going to be good nucleophiles. Okay, because again, remember our old trend was if we were going horizontally along the periodic table, nucleophilicity would parallel basicity. So really good bases are going to be really good nucleophiles. But if we're going up and down vertically, that trend is going to invert if and only if we have this polar protic situation. If we had something that was non-protic like DMSO, that good nucleophile, good base trend would continue. Okay, so between these two, we can talk about the conjugate acid of each one of these and figure out which one is going to be the better base. So you can, compare and contrast to the thiol, and you can compare and contrast to the conjugate acid of this ethoxide, which would be ethanol, and you could then say, okay, pKa for all of these guys, this is going to be about 9, this is going to be about 15. Okay, so this is the stronger acid, so weaker base. This is going to be the weaker acid, so the stronger base. Okay, and again, this trend will hold exactly the same for the conjugate base of both of these. So between these two, this is also going to be the weaker base, and this is also going to be the stronger base. Okay, so again, when we're comparing the conjugate base of the thiol and the conjugate base of the ethanol, we can say that this compound, the conjugate base for the thiol, is actually going to be a better nucleophile than this ethoxide. So now the only thing we have to compare and contrast is, between these two, we have to figure out where this conjugate base of acetic acid is. Where is this carboxylate going to stand in terms of its nucleophilicity? Okay, so then what we need to compare it to is, as close of an apples-to-apples comparison as possible. So what we have here is an oxygen that's negatively charged. What we should compare it to is if we have another oxygen that's negatively charged, that would be fantastic. And we do. We do have an oxygen that has a negative charge. So if we're going to compare and contrast, it's going to be easy to compare and contrast this carboxylate to this ethoxide. Okay, so let's just think about, for a second, the pKa of the conjugate acid of this guy. So just put this on our list. So we have our carboxylic acid, OH, and it's going to have a pKa of 4. So between the carboxylic acid and the ethanol, the carboxylic acid is going to be the stronger base. Okay, so let's use a different color here. Let's use yellow. So if we're comparing this guy to this guy, this is going to be a stronger acid, weaker base. And so the ethanol is going to be the weaker acid, stronger base. Okay, and in this case, when we're comparing this oxygen right here, this negatively charged oxygen to this negatively charged oxygen, we are not going vertically along the periodic table. We're actually going horizontally. So we don't really have to worry so much about this inversion of nucleophilicity basicity. So we can actually just go ahead and draw a direct trend. And between these two, the stronger base is going to also be the stronger nucleophile. So since the stronger base is also going to be the stronger nucleophile, this stronger base right here is going to be the stronger nucleophile. So strong nucleophile and then weak nucleophile. Okay, and then going back to the original comparison between the conjugate base for the thiol and the ethanol, we said that again, because we're going vertically along the periodic table, the nucleophilicity basicity trend is inverted because we're in methanol. So since we're in methanol and the nucleophilicity basicity trend is inverted, the weaker base is actually going to be the better nucleophile. So let's go ahead and fill that in. So weaker base is strong nucleophile and then weak nucleophile. Okay, and again, this is just comparing. This is just comparing these two together. Whoops. And then we're comparing these two together right here. Okay. So between the carboxylate and the ethoxide, we know that the carboxylate is going to be a worse nucleophile than the ethanol. Okay, so this is going weak to strong. So we know that the carboxylic acid is weaker than the ethanol, and we also know that the ethanol is weaker than the conjugate base for the thiol. So we're going to have to put this guy here. So this is our strong to weak trend. And we had to, remember, do two things here. We had to compare across as well as along the periodic table. Okay, so don't forget that these can potentially invert once you start comparing vertically. That's the big issue here. All right, so then going on to the next sub-question, water and ammonia in methanol. So ammonia and water, the nucleophilic bit is the nitrogen and the oxygen. Those are on the same row, so the fact that it's in methanol really isn't that big of a concern to us. So because of that, we can just compare pKa directly. So again, pKa for the water is 15, pKa for the ammonia is 40. So this is going to be the stronger acid, weaker base, and this is going to be the weaker acid, stronger base. And so because, again, we're going across the periodic table, basicity will parallel nucleophilicity. So this is the strong base, strong nucleophile, weak base, weak nucleophile. Okay, so between these two, decreasing nucleophilicity is going to be, this is the weakest, this is the strongest. Okay. All right, next question.